Welcome to qnawire.
As the disks are connected, their angular momentum is conserved, but some of their initial kinetic energy is converted to thermal energy, and we know that 2400 joules of energy is being converted to 2400 joules of thermal energy is equal to the loss of rotational kinetic energy. So from the angular momentum conservation, we know that I1 omega 1 is equal to I2 omega 2, where this is the angular momentum of the system, or in our case, when the disk A was only rotating, and this is when disk A and B are rotating together. So this part can be written as IA omega A, and for this part, or the final part, um, it can be written as the total moment of inertia of A and B times omega. Now from there we see that omega is equal to IA omega A divided by IA plus IB, and loss of kinetic energy delta K is basically the initial kinetic energy minus the final kinetic energy, which is equal to half of IA omega A. Again, the reason is that initially IB was, or the disk B was not rotating, so we only have kinetic energy contribution from disk A. Then we subtract that from the kinetic energy after disk B was attached, which is IA plus IB times omega squared. Now, if we combine these two equations, so the way we combine that is we replace omega, and we'll see, we replace omega here, so we'll see that delta K is equal to IA omega 0, or in our case omega A, divided by 2 I minus IA divided by IA plus IB. And if we solve for the thermal energy loss, we see that the loss of kinetic energy should not be more than 2400 joules. So then we'll have an inequality, which is IA omega A squared divided by 2, 1 minus IA by IA plus IB. And this quantity right here should not be greater than 2400 joules. And from here we can see that this part right here is the kinetic energy of disk A, so we can substitute that by Ka. So we'll have Ka, which is times 1 minus Ia by Ia plus Ib, which is less than equal to 2400 joules. And from there we see that Ka should be less than equal to 2400 joules times IA plus IB by IB. And since we're given that IA is equal to IB by 3, so by the way, IA is the moment of inertia for disk A, and IB is the moment of inertia of the disk B. So that's why we can use this condition over here. And so from there we see that maximum kinetic energy of A will be 3200 joules. So that's less than equal to 3200 joules. So Ka, let's say max, should be equal to 3200 joules. Thank you.